Okay, Math Masters, today's quick lesson is on bisecting angles. You probably remember the word dissect in biology. It means to cut open, and the word bisect means to split in half. So we can split lines in half, or we can split angles in half. So each angle would have one bisector because we'd be splitting that angle in half. Let's take a look in the real world where you'd see some angle bisectors, and you should be familiar with some of these. So in the first example, you can see how we have a home plate, we have a baseball diamond, there's third base line and first base line, and we can split that right down the middle. That would be splitting a 90-degree angle into two equal angles that are 45. Most of these angles you'll see are similar that way. There's an angle on a clock over here, another 90-degree angle, 3 o'clock, which has been split in half by this angle bisector to give us two 45-degree angles here. Same thing with on this football, and this piece of pie has been split also into this angle, and this piece of pie has been split into two parts. All right, let's go to another slide and see if we can see, or just by visualizing, which angles have been split in half. The first one, it looks to me like this angle. You remember this symbol here, theta. It looks like it's equal, so because of that, this 90-degree angle looks like it's been split into two equal parts. I'll give you a chance to look at the other four angles and see if you can see any others that have been bisected. This angle down here is actually the symbol for perpendicular. So you'll notice that this line here and this line here meet at 90 degrees, and of course this side over here must also be 90 degrees. So this line right here would actually be an angle bisector. Looking at this acute angle, it's been split into two equal angles where theta would equal theta. And these last two do not look like we have an angle bisector, because you'll see that this angle theta here looks like it's smaller than this angle beta here, and this angle theta right here looks like it's smaller than this angle beta right here. Okay, let's try another practice question. It says find the size of each of the equal angles. So there's two questions here. The first question deals with a triangle, and one of the angles on the triangle has been split. So the triangle is in blue. You'll see one of the angles is 80 degrees. That's an acute angle. Another of the angles is 60 degrees, also an acute angle. So adding 80 degrees plus 60 degrees, we'll get 140 degrees. So knowing that the interior angles of a triangle add up to 180, let's subtract the 140, which leaves us with a remainder of 40 degrees. So this last angle at the bottom has to be 40 degrees. Splitting that in half, the two angles we'll get down there at the bottom, let's call this vertex A. We would say those two angles would be equal to 20 degrees, because 20 degrees plus 20 degrees would give us 40 degrees. Finally, looking over at B, we recognize the symbol for perpendicular, so we'll see a perpendicular line there. It looks as though there's potentially an angle bisector here, which would be 45 degrees here, and then we would be splitting the remaining 45 degrees into two sections, which would give us 22.5 degrees, followed by another 22.5 degrees. My head's kind of in the way there. All right, our geometry sets. Hopefully everybody has a geometry set at their disposal. I've bisected one of these angles. I'll put that video up as well online, but I'm going to use this tool right here to bisect another angle. Let's take it over here. I'm going to put the end point of my compass on the vertex. I'll take my pencil. It doesn't really matter how wide this is. I'm looking to mark points that are equidistant. So I'm going to mark a point here on this arm, and I'll come over and mark a point here on this arm. So that point right there and that point right there are equidistant from the vertex where I have my protractor or my compass in there. I'll lift my compass up and I'll move over here to one of the locations, either on this arm or the other arm, and I'm going to have to make another mark. So I'll take my compass out. It doesn't really matter where I put that adjustment. It does make a difference though where I put this next mark. coming off the screen. Alright, so I need to mark over there. I'm going to lift up my compass, and I was having a hard time because of the angle I'm trying to bisect. My compass falls off the page. Now I've made a mistake because I've changed the adjustment on that. So hopefully this works out to be straight. I'm going to draw a straight line, and I'm going to join this point to this point, and I've bisected that angle. Alright, a couple of questions for you to practice if you have some blank paper at home. Is one to draw a scalene triangle. Hopefully you remember what that is. If not, you're going to have to do a quick search online. It's a special kind of triangle. And then bisect each of the 3 angles of that triangle. Another practice question, if you have some paper at your disposal, which again I hope you do, is a folding activity. You're going to make a fold, which will create an angle, and then you'll make another fold. Hopefully you have the 2 arms falling on top of each other to bisect your angles there. Right, and then we will move to our jump math for completing our homework today, which is page 117. There'll be some other videos available if you need some help on that. So hopefully things go well. Take care, and I'll talk to you soon. Bye-bye.